Okay, my friends, so for our second and last study of the day, we're going to look at green tea and the prevention of breast cancer. Go ahead and open that PDF linked next to this playlist. Read through it. I would hit pause on this and then come on back when you've gotten a chance to. Okay, so before we get into the nuts and bolts, because we're going to be forming hypotheses in this study and looking at the p-value they got there, there's a couple terms that might throw you for a little bit of a loop here. The first one, women years. Notice they're not talking about years or women, they're talking about women years. This is kind of like the phrase acre feet in water. When they measure an acre feet, it's a more logical unit for dealing with certain fluid ideas like irrigation, where you're talking about a large amount of water. It makes more sense than gallons or cubic feet, for example. Women years, from what I understand, is better than just using women, because a woman can live for a very varied amount of time. Anywhere from, well, I mean, you could live to be over 100 or you could die very young. So women years is kind of a per capita, where they can, you know, if somebody lives to be 80 and somebody else lives to be 40, that's going to be 120 woman years, which makes more sense than just calling it 2 women. A couple other things I noticed about this study. There's a reference to yielding null results. I bolded it because I thought that was important. We're going to come back to that later, but it's the idea of a study that was done and was not able to find statistically significant differences. So in other words, large p-values. We're going to see small p-values quite a bit here, but we're also going to see large p-values in the next day's playlist of videos. And at the very bottom, again, this is not a research methods class, so I don't want to get hung up on it too much, but they mentioned the way they did the study by having 2 groups of people. The idea is that green tea consumption is being tied to a decrease in breast cancer rates. Okay. The only problem is, and again, you can check out the original study. That's why I linked the original studies up in the title for you. As soon as you let somebody, you bring them in, you measure them, and you let them go back into their world, there's going to be environmental factors you can't control. And that's always the nervousness I have with a study like this. When you bring people in, take a measurement or questionnaire, whatever, and then let them go back into their world, because all of a sudden there's all these other things that might be impacting their overall cardiovascular health besides the consumption of just green tea. So just little things like that catch my attention. I figured I'd talk about them a little bit here before we get into the nuts and bolts. As I said earlier in the previous video, we're not going to question the research methods. You can take an entire class on research methods if you want to. We're just focusing on the nuts and bolts of hypothesis testing, in particular that p-value. We'll get to that in a second. All right, let's keep going. Okay, so let's figure the hypotheses out that this study was working with. So we know there's a null, and we're going to assume that until proven otherwise. And we know there's an alternative. Let me give myself some more room to write. There we go. Okay. Since I've already read the study's title, I know what they're trying to show. They're trying to show that green tea decreases the incidence of breast cancer. That's what they want to show. That's what they want to show, that green tea decreases the incidence of breast cancer. Now, some of you watching this video are probably going to say, like, duh, we know it does. But how do you know it does? If that's you saying that. Maybe you're not saying that, and if so, just sit tight. We'll get to that in like 30 seconds. But if you're saying that, how do you know that green tea lowers the rate of breast cancer? Because studies have been done on it. But the first study that was ever able to show that green tea, the antioxidants in green tea, actually had a deleterious effect on cancer cells, before that study was done, green tea was just like Coca-Cola, was just like coffee, was just like red wine, was just like, Monster energy drink. Why would any of them have a lowering effect on breast cancer rates? There's no reason to think it is until studies can support it. So the null is that green tea does not. Green tea does not have, how did I say this? Does not decrease. Make sure I say it the same way. Does not decrease breast cancer incidence. I gave myself enough room and I still can't. I still ran out of space. So those are your hypotheses. The research wants to show that green tea decreases the incidence of breast cancer. The null hypothesis says, why would it? Why would it? Now, the study was done. I'm not going to question the research methods. The study was done. They got a p-value. Let's look at a graphical representation of that p-value and the sampling distribution on that null hypothesis. Okay, my friends, so here is the conclusion from the report. Green tea consumption was associated. I like that they said associated and didn't cause. At least they're admitting that there's an association and not necessarily a causation. With a reduced risk to breast cancer with a statistically significant test for trend. P is less than 1 in 1,000. Okay. The only thing that we really have to worry about mechanics-wise is that P is less than 1 in 1,000, and I want to break that down with you right now in this video. Okay, so first of all, that, my friends, is what the null hypothesis sampling distribution looks like. We, quote-unquote, know the risk of breast cancer in the general population. It's going to be right here on the center of this sampling curve, brought to you by the central limit theorem. Now, you don't have to be exactly at the center to be usual. You can be within variation of the center. But why do we say elevated here? Why do we say elevated? Well, think back to the research hypothesis and the conclusion that you're seeing right here above. They're trying to show that green tea consumption reduces breast cancer. The opposite of reduces is does not reduce. Okay, so what does that mean? Well, it means two things. It might stay the same, which would be it would be usual, or it might even get worse, which would be elevated. That's why this, dear friends, is a one-sided confidence interval. Still 95% of the area, just like a two-sided interval. But the null hypothesis has to cover not just the it stayed the same part, the usual part, but it also has to cover the elevated part. Now, that red area over there is going to represent the unusually low cancer rates. So the question is, this is the setup, right? This is the sampling distribution for the cancer rates. Where did the study's result land? Well, that p-value tells you where it landed. You see how it says it's less than 0.001? That means it had to have landed somewhere in this tail. It has to. It's such a small probability. It couldn't have landed in the 95% range. It's way, way less than 5%. Remember, this red area right here, if this is 95%, this red area is 5%. If the area here is less than 5%, that means it must have landed in this tail right here.